Alfred Tarski, a titan of logic and mathematics. Alfred Tarski, born Alfred Teitelbaum on January 14, 1901 in Warsaw, then part of the Russian Empire, was a preeminent Polish-American logician and mathematician whose work profoundly influenced various fields including logic, mathematics, and philosophy. Tarski's extensive contributions to these domains mark him as one of the most influential logicians of the 20th century. His journey from Poland to the United States and his groundbreaking work in formal logic, set theory, model theory, and algebra are testaments to his intellectual prowess and enduring legacy. Early life and education. Alfred Tarski was born into a Jewish family and displayed an early aptitude for mathematics and logic. He studied at the University of Warsaw, where he was influenced by prominent Polish logicians and mathematicians, including Jan Łukasiewicz and Stanislaw Lesniewski. Tarski's early work was heavily influenced by the Polish school of logic, which emphasized precision and formalism. In 1924, Tarski completed his doctorate under the supervision of Lesniewski. His doctoral dissertation on the concept of truth in formalized languages laid the foundation for his later, more extensive work on the same topic, Contributions to Logic and Mathematics. Tarski's work can be broadly categorized into several key areas: the theory of truth, set theory, model theory, and algebra. Theory of truth. One of Tarski's most famous contributions is his semantic theory of truth, articulated in his seminal 1933 paper, The Concept of Truth in Formalized Languages. In this work, Tarski sought to provide a rigorous definition of truth for formal languages. He proposed that a statement is true if it corresponds to reality, encapsulated in his convention T. A formally correct definition of truth should entail all instances of the schema P is true if and only if P, where P stands for any statement. Tarski's definition of truth aimed to preserve the classical correspondence theory of truth while providing formal precision. This work addressed significant philosophical issues concerning the nature of truth and had profound implications for the development of formal semantics. Set theory. In set theory, Tarski made significant contributions, particularly in the study of cardinality and the axiom of choice. He proved several important results regarding the nature of infinite sets and cardinal arithmetic. His work often intersected with that of other prominent set theorists such as Kurt Gödel and Paul Cohen. Tarski introduced the concept of inaccessible cardinals, which are certain types of large cardinals used to study the structure of the set theoretic universe. His contributions to set theory have had a lasting impact on the field, influencing both the foundational aspects of mathematics and more applied areas. Model theory. Tarski is also considered one of the founding figures of model theory, a branch of mathematical logic that deals with the relationship between formal languages and their interpretations, or models. He introduced the notion of elementary equivalence and developed tools for analyzing the properties of models of different theories. His work in model theory included the development of techniques for constructing models and proving their properties, which has applications in various areas of mathematics and logic. Tarski's insights in this area laid the groundwork for later developments in the field, including classification theory and stability theory. Algebra and universal algebra. In algebra, Tarski's contributions are equally significant. He worked on universal algebra, which studies algebraic structures in a very general setting. His research in this field led to the development of various algebraic theories and influenced the study of algebraic logic. Tarski's influence extended to areas such as lattice theory and the theory of Boolean algebras. His work on cylindric algebras, which are algebraic structures related to the semantics of predicate logic, provided important connections between algebra and logic. Emigration to the United States. The rise of Nazism in Europe prompted Tarski to emigrate to the United States in 1939. He accepted a position at the University of California, Berkeley, where he would spend the remainder of his career. At Berkeley, Tarski established a renowned school of logic, mentoring numerous students who would go on to make significant contributions to mathematics and logic. Tarski's teaching style was rigorous and demanding, but he was deeply committed to his students' development. His influence at Berkeley helped establish the university as a leading center for research in logic and mathematics. Philosophical impact. Tarski's work has had a significant impact on philosophy, particularly in the areas of philosophy of language and epistemology. His formalization of the concept of truth has been extensively discussed by philosophers, and his ideas have influenced various philosophical debates. Tarski's contributions to the philosophy of language include his analysis of the semantic paradoxes, such as the liar paradox. His work provided tools for addressing these paradoxes within a formal framework, influencing subsequent philosophical research. Legacy and honors. Tarski's legacy is vast, spanning multiple disciplines and influencing generations of logicians, mathematicians, and philosophers. He received numerous honors and awards in recognition of his contributions, including membership in the National Academy of Sciences and honorary degrees from several prestigious universities. He continued to work and publish prolifically until his death on October 26, 1983. His collected papers, published posthumously, remain a valuable resource for researchers and scholars. Conclusion. Alfred Tarski's intellectual contributions have left an indelible mark on the fields of logic, mathematics, and philosophy. His work on the concept of truth, set theory, model theory, and algebra has provided foundational insights and advanced our understanding of these complex domains. Tarski's rigorous approach and profound insights continue to inspire and influence contemporary research, underscoring his enduring legacy as one of the greatest logicians of the 20th century.